Welcome to our next lesson in our unit on similarity. Today we're going to start proving that triangles are similar. From our investigation, you should have noticed that when two angles of one triangle are congruent to two angles of another triangle, then the two triangles will be similar. In our diagram right here, angle A is congruent to angle D, angle B is congruent to angle E, so therefore the two triangles ABC is congruent to triangle DEF. Notice that when you write the similarity statement, you want the angles that are congruent to each other to be in the same position in your similarity statement. Be really careful of that when you're asked to write a similarity statement. Now we're going to start using the angle-angle similarity theorem to determine whether some triangles are similar or not. If they are, we're going to write a similarity statement and then we're going to explain our reasoning. In example 1a, we have two right triangles. So since there are two right angles, we know that the right angles are congruent to each other because they're both 90 degrees. We have two other angles, one is 26 degrees and the other one is 64 degrees. Let's find out what the missing angle measure is so that we can see if there are two angles that are congruent to each other. So I subtract 90 and 26 from 180, and this gives me that the measurement of angle E is 64 degrees. This means that angle E and angle H are congruent to each other. Since we have two angles of one triangle congruent to two angles of another triangle, we can use angle-angle similarity to say that these two triangles are similar. Therefore, triangle DEC is similar to triangle GHK. There's my explanation. By AA similarity, angle D congruent to angle G and angle E congruent to angle H, we can say these two triangles are similar. Let's do this one more time. Let's go over here to B. We want to determine whether the triangles are similar by AA. Angle F and angle C are congruent because they both have a measure of 30 degrees. Now we just need to find one of the measures of the missing angles to see if we have another pair of angles that are congruent. So I found that the measure of angle E is 106 degrees, the measure of angle A is 34 degrees. Therefore, we only have one pair of congruent angles. We don't have the two that we need, so these two triangles are not similar. There's my reasoning. We don't have two pairs, so I'm actually three pairs of congruent angles. I'll let you guys try C, and then we're going to move on to example 2. For this next example, we're going to be using the angle-angle similarity theorem to show that the two triangles are similar. So we're going to need to find two angles that are congruent in all the triangles that we're given. For example A, we're asked to show that triangle ABE is congruent to triangle ACD. What I notice is that angle ABE and angle ACD are congruent. Now we have to find out what our next angle that is congruent. Let me quickly highlight the two triangles that we are trying to show that are similar. In our similarity statement, we need to show that angle A is congruent to angle A or angle E is congruent to angle D. At the moment, we have no information that tells us whether these two angles are congruent. However, angle A is angle A. Notice that the small triangle ABE and the bigger triangle ADC, they both share that angle A. So, because they both share that angle A, that's another pair of angles that are congruent. Since we have two pairs of angles that are congruent, then we can say these two triangles are similar. Here's my explanation. Angle ABE is congruent to angle ACD because they have the same measurement. They both have a measurement of 52. And angle A is congruent to angle A by reflexive property. It's the same angle. So therefore, we have two triangles, ABE and ACD. They're similar by angle-angle. Let's do example D. This time, we're not told which two triangles are similar, so we're going to have to figure it out using our reasoning. Something that I noticed is that there are some parallel lines. And when there are parallel lines, there are going to be angles that are congruent. Let's see if we can find some. So I noticed that angle PQS is congruent to angle QSR. And this is by alternate interior angles. Additionally, since PS and QR are parallel, we have one more pair of alternate interior angles, angles PSQ and angles SQR. Therefore, we have two angles that are congruent in both pairs of triangles. So now let's explain our reasoning. So we have two pairs of angles that are congruent because they're alternate interior angles. Now we need to write our similarity statement. So my tip to you, just find the angles that are congruent and then write it in that order. If I start off with angle S in this triangle, S is congruent to Q in the other triangle. So I'll start off with S for the first triangle and then Q for the next one. Then I'm going to go to Q for this top triangle. The angle that is congruent to Q in our other triangle is S. Then we just have one more vertex of each triangle. That one's going to be congruent by default. So P and R. So I get as a final answer, triangle SQP is congruent to triangle QSR by angle-angle similarity. For F, we're showing that triangle QPR is congruent to triangle QTP. So this one's kind of similar to A, where we have a angle that is shared within both of the triangles. Notice that they both share angle Q. Additionally, they both have right angles, and those right angles are also going to be congruent because all right angles are 90 degrees. So we just need to state that those two pairs of angles are congruent, and then we'll be finished. So I get angle Q is congruent to angle Q by reflexive property. Angle QTP is congruent to angle QPT since they are right angles. And so therefore, triangle QPR is similar to triangle QTP by angle-angle similarity. So you can use this as shorthand if you don't want to write out similarity every time. We're going to move on to our last example. We're going to end off with a word problem. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby, who is 5 feet 4 inches tall, casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? So I'm going to start off by drawing a diagram. Here's my diagram. This is the flagpole, and this is the shadow that the flagpole casts. This is the woman, and this is the woman's shadow. Notice that we have two triangles here, and these two triangles are actually going to be similar. For all the word problems that you get like this, the two triangles that are created are similar. So that means that the sides are going to be proportional. And then we're going to write a proportion to figure out the missing side length. Issue here is that we have one measurement given to us in feet, another in feet and inches, and then another one in inches. So you're going to want to convert so that they're all the same units. I'm just going to convert to inches and then convert back to feet because the answer wants our answer in feet. So I get that the shadow of the flagpole is 600 inches. The woman is 64 inches tall. Her shadow is 40 inches. So now we can write a proportion to solve for the height of the flagpole. I get x over 64 is equal to 600 over 40. I'm going to reduce the fraction on the right-hand side because we can. I get x over 64 is equal to 15 over 1 after I reduce, and then we just have to cross multiply, and then we have our answer in inches. I get that x is equal to 960 inches. Then we just have to divide by 12 to get our final answer because there are 12 inches in a foot. After you divide by 12, you get 70 feet. So the height of the actual flagpole is 70 feet. Problem B, you can do that very similarly. Just draw two diagrams and then write a proportion. That's it for our lesson today. Let me know if you have any questions, and take care.